Part A. Is rectangle A a scaled copy of rectangle B? If so, what is the scale factor? Now, if rectangle A has a length of 12 and a width of 8, and rectangle B has a length of 15 and a width of 10, we can find the scale factor by finding the multiplicative relationships of both lengths and widths. Now 12 times 1 1/4 equals 15. And now if 8 times 1 1/4 equals 10, which it does, we can determine that rectangle A is a scale factor of B, because the relationships of each rectangle's lengths and widths are the same. So the scale factor for part A is 1 1/4. Part B. Is rectangle B a scaled copy of rectangle A? If so, what is the scale factor? This is pretty much the same and has the same scale factor of 1 1/4. But to determine if that's correct, we can just divide the lengths of rectangle B, 15, by 1 1/4, which gives us 12, the length of rectangle A. And if we divide the width of rectangle B, 10, by 1 1/4, we get 8, the width of rectangle A. So yes, rectangle B is a scale factor of rectangle A. Part C. Explain how you know that rectangle C is not a scaled copy of rectangle B. Rectangle C is not a scaled copy of rectangle B because the relationships between each length and width does not stay the same. 15 times 2 equals 30, but 10 times 2 equals 20, which is not the same as rectangle C's width of 15. So these two rectangles cannot be scaled copies of each other. Part D. Is rectangle A a scaled copy of rectangle C? If so, what is the scale factor? Rectangle A is not a scaled copy of C because the multiplicative relationships of the lengths are not the same. Rectangle A's length of 12 times 2.5 equals 30, but A's width of 8 times 2.5 equals 20, making these relationships different.